Okay, so welcome to this video. In this video, we're going to discuss derivatives mixed practice. So what we've done now is we've covered all of our differentiation and how we're going to handle taking these derivatives of these functions. And now what we can do is we can discuss different options as to how to work a problem. So I'm going to show you some different approaches to some of these so you can see some options that you have, and you can be thinking about which way you like best, okay? So some of you, with this first problem here, you're going to look at that and you're going to think, oh, I should do the quotient property, okay? So if you want to approach it that way, then you're going to go about this using quotient, all right? And you're going to think to yourself, low D high minus high D low over low low, all right? So it's going to be low D high. Now the top number is just a constant and the derivative of a constant is 0. So that'll be a 0 there, and then minus high D low, the derivative of the bottom is 1, and then all over low low, like that. So since we have a 0 here in the top, that's going to cancel that first term. So on the top, I just have a negative 1, and then on the bottom, I have n minus 4 squared, okay? And this would be your answer if you went about it that way, okay? Now, another way to look at this one would be to think, oh, I can do chain. If you want to go about it using the chain property, then you're going to need to do a rewrite. Whoops, I almost made a mistake there. A rewrite. And I'm going to think of this as m minus 4 to the negative 1. And then I have this set up to do the chain. So when we do chain property, we're doing the derivative of the outside, and then we're multiplying to the derivative of the inside. And then since these are just ones, I've got a 1 here, I can kind of think about canceling that out. And I can just write my answer as negative m minus 4 to the negative 2. If you want to put the negative 1 there, you can, that's fine. Okay, so if you did chain, that's how you would write your answer. Okay, so looking at these two, they are equivalent to each other, right? They look a little different, but if you really think about simplifying out the negative exponent, they are the same. Okay, so either one of these are fine. So whichever way you want to do the problem and whichever way seems easier or better to you, then that's the way you should do it. Okay. All right, if you'll look at this next one here, I'm going to show you a couple of different approaches as to how you could do this problem. Some of you will look at this and you'll think quotient. Okay, and so when I do quotient and then I have to do the derivative of the bottom, then I'm going to bring in the chain there. So we would call this quotient with chain. So what we're going to do here is we're going to start with our quotient. So we're thinking low D high. The derivative of the top is 4 minus high D low. And this is where I've got to bring in that chain, okay? So I'm going to do chain on that bottom. So remember, chain is derivative of the outside times the derivative of the inside, okay? And then I've got this all over low low, which would look like that, okay? And then let's just clean this up just a little bit here. So I can bring the 4 to the front, and I can multiply, okay, I can multiply the 4x with the 5 and the 1, and that's just going to be a 20x, and I'm going to write that on the front here. Okay, and then I can simplify, so I can multiply that 5 and 2 together, and that'll be a 10. Okay, so I can write my answer a little bit simplified in this form here. Okay, remember we talked about how simplifying it a little bit is going to help us when we have to key these derivatives into Excel. All right, now another way to look at this problem, okay, and some of you would think of this as a product with chain, okay? So if I'm going to do product with chain, I'm going to want to do a rewrite like that, okay? And then I have a product with chain. And if I want to do it that way, all right, we've got, we're going to go through our, what we say to ourselves, first times derivative of the second, okay? So this is first here, and this is second, by the way. And when I do derivative of the second, that is going to be my chain. And remember, chain is derivative of the outside times derivative of the inside. And then it's going to be plus derivative of the first, which is 4, times the second. Okay, and then I'm going to clean this up a little bit. I can multiply the -5 with the 4x with the 1. So I can say a prime of x is -20x, and then x minus 9 to the -6 plus 4 times x minus 9 to the -5. Okay, and then if I did it this way, this would be how I would write my answer. Okay, and believe it or not, these two answers are equivalent. I know they look very different. If you kind of want to challenge yourself, you could, look at taking this answer here and seeing if you can get it to match that answer there, just using algebraic simplification. That's actually kind of good to practice that, so you can kind of get used to understanding when answers are equivalent to each other. But if you just want to trust me and just trust what I say here, that those are equivalent, that is also fine. So anyways, like I said, I'm trying to help you understand you have some options as to how you work these problems. And when you work it one way versus the other way, your answers are a lot of times going to look kind of different from each other. Okay, but that doesn't mean one answer's wrong. It just means they look different. All right, so let's keep going here. Got one more example for you. This is our natural log function, and with our natural log function, one thing that, sorry, trying to make some quick edits here, which is, get that little mark out of there. Okay. All right, so when we have our natural log function, these can always feel very tricky, okay? And just you have to really be slow on these, okay? So I'm going to show you two approaches. Now, one is better than the other in my opinion, but I'll show them both to you so you can just be thinking about that and how that all works. So the first approach would be, hey, we've got a natural log with chain, okay? Because my outside function here is this natural log, and then when I go to do the derivative of the inside, that's going to be a chain, okay? So remember, derivative of a natural log, you just do 1 over whatever is inside that natural log, okay? So I'm going to start with that, and then what I need to do is then use my chain, okay, because I've got a situation here on the bottom where I have the chain property to take the derivative of that. So I have to multiply by do the derivative of the inside. Sorry, I got tongue twisted there. Okay, so that is going to be 2 okay, sorry, 2, and then I've got b squared minus 5b to the 1. You don't have to write the 1. I'm just kind of emphasizing that my exponent decreased from 2 to 1. And then you remember to multiply by the derivative of the inside. This is a piece right here that a lot of people forget to do. Okay, so make sure you remember to do that. Okay, and then just to write that. Okay, so what I can do here is I can just sort of combine that to multiply that out. Top times top and bottom times bottom. So I have that. You can actually simplify this one a bit further if you are looking to simplify, because you have this factor on the top and then you have two of those on the bottom. So you can actually simplify out one of those factors from the top and bottom. So if I take the b squared minus 5b out of the top, and I've canceled that with one of the b squared minus 5b's on the bottom, then I would have this as my answer. Okay? All right, so if we look at another approach to this problem, which I actually really wouldn't recommend this, but it's it's just good for us to discuss this because it's just good to understand your options, I think, when you're working with derivatives. So you could multiply this out, okay, in the middle here and do a little algebraic simplification. And so I'm just going to write that here really small. So that's b squared minus 5b times itself, b squared minus 5b. And so I'm going to get a b to the fourth, and then I'm going to get a minus 5b cubed, and then another minus 5b cubed. So that'll be minus 10b cubed, and then plus 25b squared. Okay, so I could simplify there. Okay, and so my a of b would then be this. Okay, and then what you would have then is a situation where you have some layers to this. You're going to first kind of think about your outside function as that natural log, and it would be 1 over what you have inside of that natural log, like that. And then you would need to multiply by the derivative of this b to the fourth minus 10b cubed plus 25b squared. Okay, so then you could clean this up a little bit. Sorry, my pen is being a little stubborn, all the bouncing around. Let me double check myself here real quick. I'm trying to write fast and make sure I didn't leave an exponent out somewhere. Okay, so believe it or not, sorry, look, I've got to make some adjustments here. I should have a prime here because this is my derivative. All right, I knew I needed to check behind myself. All right, so believe it or not, this answer here is equivalent to this other answer that we had over here. But you can see it's a lot messier, and that would be, I feel like, a lot a lot harder to key into Excel. So I would not recommend this method just because I just feel like it's a lot more, there's a lot more exponents and things you've got to keep up with. I feel like this would definitely be the better choice, although both of these answers are correct and actually do simplify down to be the same thing. Okay, so like I said, just trying to show you some options so you can just kind of see, some different ways you can approach problems, because a lot of times one option maybe will be a lot easier than another. And so when you just understand your different approaches of how you can go about doing a problem, that just gives you more choices and more things that you can do to maybe make the problem a bit easier. Okay. So anyways, work hard on your derivatives, and I will see you guys in the next video or back in class.